Welcome back to Daily LeetCode. We are back once again. We're wearing the Attack on Titan drip. So, if you don't know what Attack on Titan is, we're going to ask you to comment hashtag Aaron did nothing wrong, hashtag the euthanasia plan is the right plan, hashtag the rumbling is coming. So, we're back once again. We have some comments, and it's not 117. It is now day 100. I can't delete the last character for some reason. Oh, finally. Okay. It's day 118. I was getting really frustrated with the Windows keyboard. The Windows operating system is an inferior operating system. Someone has to say it. The Windows operating is an inferior operating system. Well, I couldn't change the caps lock key to control, which was giving me quite a bit of frustration. So we switched to the HHKB today. I haven't used this. I don't even use this keyboard. I haven't used it in a very, very long time. In fact, the keyboard I usually use looks a little something like... There's quite a few different keyboards. But this, if you want an absolute banger of a keyboard, look at this beauty right here. This is a BTC 5100C, okay? And you know how this keyboard doesn't make any sense. You've never seen a connector that looks like this before, okay? You gotta the weird ones know, okay? This whole thing goes inside your motherboard, okay? So yeah, this keyboard's pretty cool, but it doesn't work. And I was hoping that I could send it to someone so that they could fix it for me, but I don't know if I'm sure someone on Etsy does that, but I don't know. But it's a legendary keyboard. It feels amazing to type on. That's besides the point. But you know what it feels amazing to type about? LeetCode. So we have some comments here today. We have from a name I will never know how to pronounce. I like your effort. Most LeetCode solving videos time around 10 to 20 minutes without any explanation or struggling. True! I want to see the process as a normal IQ developer. Thank you for your video. It helps a lot. You are most welcome. You're most welcome, fellow algorist. True. Yeah, I always find that very interesting. And I remember, I feel like I always wonder if when someone's trying to, like when I was younger, and I remember, I say that like I'm really old, but I feel like just being able to see how something works, or how it feels to do something, or how it comes off to do something is pretty cool. So I remember seeing, I don't know how to explain it. It's like there's like a mental blockage. Like, for example, when I was younger, me and my brothers used to take apart computers, and it was mostly my eldest brother who would lead the charge on taking apart computers. But when the first time we did it, this seemed like a task that was impossible, you know? That it was like, you can only do this if you were like a hacker, or you were, this is a while ago, and I was like maybe 10 or something, maybe even younger. But it just seemed something that was like impossible. But I remember doing it with him, and he would just figure it out as he went, and we would take things apart. He didn't know what something was, so we'd Google it, or we would just kind of take our time and try and like figure it out. And then it just made me realize like I didn't have to know every step like to try something, which is just a very interesting experience. Because most of the time I'm worried about trying something. I haven't thought of like. It's just that I haven't been exposed to seeing that you can struggle through something and do it, which is pretty interesting. So I think it's always cool to see that, someone struggling. It's like those videos where like a budding filmmaker will see their film, their dream director struggling to come up with an idea, or a budding artist sees their sees like their favorite artist like struggling with something. And this kind of relates to Kim Jong-gi, but in some videos you can see him like pause and actually think about drawing, and it's like, oh, like it's okay for him to stop and think and draw, and it kind of just washes away the idea that like I had to already know how to put every line. I'm not saying I'm anywhere near like the example for LeetCode would be like Colin Galen or any of the other people on like LeetCode who are like going crazy, but I'm just saying it's cool to see that helps, because I like to see that too. But have fun with Q3. Yeah, we got fried by Q3. comment from T Wong the legend. We got absolutely bodied by Q3. Actually, we didn't really get any much time, but it felt like a graph problem it felt like a topological sorting problem. I can't remember if I'm thinking about the right problem. It was either the problem with the Q, right? Oh, no, I'm thinking about something else. It was the problem with ordering. And it seemed like it seemed like a topological sort problem, but I'm not exactly certain. Now, for the first time ever I understood what you were talking about, the first problem. Let's go! Let's go! Literally had a dream where I was solving an if-else statement and woke up to understanding LeetCode for the first time. True! I'm telling you, bro, you gotta use that Doctor Strange working while sleeping technique. True! This is very, very true, man. Yeah, I feel like sometimes I'll have those dreams. Dreams are just so strange. Dreams are just so strange. I remember reading a paper, or it was like a summary of a paper about like dreams and problem solving, and it's just very, very strange. Like the concepts we're using under the hood to interpret like the decisions we make are just crazy. I remember the paper the summary was like it was like they gave people a sequence of letters, right? There was a pattern to the letters, and it was a sequence of letters and numbers, and there was a pattern to them, right? And they gave them an increasing difficulty, so you figured out the pattern, you move on to the next level where the pattern was more difficult to figure out. And it might be something like, A, C, B, like, you add one letter, then you add another letter, then you add three letters. And you add one letter, add another letter, and you add three letters, like as an example pattern. And there are people who didn't get to sleep, basically, and keep doing it, and there are people who, when they got to the hardest part, actually, I think they got to go to sleep. And for some of the people, when they went to sleep, there was some like extra processing that happened while they were sleeping, but the mechanisms by which they were processed were just like completely arbitrary. Like there was this one woman who said that she had a dream that they're like so random. She had a dream that like her uncle as a 9-year-old was mowing the lawn in front of some random house, and then she was like, I got it, I figured out the pattern. Or then there was some other person who had like some ridiculous dream where like a spider is crawling through a tunnel inside a car or something like that, and then they figure out the pattern. But it's just so strange how like these dreams have nothing to do with the pattern, I guess at the surface level, but they help with solving. And I've had dreams where I'll be programming something, or I'll sleep, like I have a problem at work, I'll go to sleep, and then I'll wake up like immediately, and I'm just like, I have to go solve this. And it's pretty cool when it happens because it's just cool. But it's just always interesting to see that the brain is always thinking. So, feel strong, man. But, yes, there was something else I wanted to talk about. I've been working on a project recently, and it's been quite difficult. It has been quite difficult. I think of the LeetCode exposure every day. When I first started, it was very difficult. The first 70 days were very, very difficult. Because every day I was like, I have to do LeetCode. I have to do LeetCode. Now it's like automatic. Decision to start the engine is not very difficult, even though our car isn't very good, because we're not that good at LeetCode yet. But I've been doing something different. I'm trying to work on a personal project, and there's like a different kind of exposure. So I'm working on the project, and then I get thoughts like, why am I doing this? This project's not going to go anywhere. Stuff like that. They just kind of undermine the process. And I had the same thoughts when I was doing LeetCode, but it's just interesting to see. I presume, I guess, since we did the LeetCode every day, now it's easier to do it. Now it's just a matter of doing it every day. Intentionally, I presume continual exposure to creating will have a similar effect. So hopefully in 30 days, my brain will stop being like, bro, why are you doing this? So hopefully that will happen. And yeah, I guess I'm looking forward to that, because coming into contact with those feelings is kind of frustrating. But yeah, it's just very interesting to see. But I know the solution, and the solution is to just commit to the smallest amount. So I think I commit to a minimum of 30 minutes of building something. And yeah, I think that should work for a good minute, like maybe a while. But I'm doing more than that. It always turns out to be that the hardest part is always just starting. When I just tell myself I'm going to do 30 minutes, I'm like, okay, I'll do 30 minutes. I always end up doing more. So The hardest part is always just starting. So yeah, just some thinking. But you know what? It's not hard to start doing LeetCode. So we have a problem that we were working on the other day that we haven't finished. Oh wait, problem three was using a robot to print the lexicographically smallest string. Should we stay on this problem? You know, we'll put another hour into this problem and see if we can solve it. Just to see, because we spend a lot of time doing easy, so we might as well spend at least a little bit of time on the weekly contest. So we'll put another 20 minutes. I'd like to continue making progress. We'll put some more time into this, right? But what you're going to want to put more time into is the hyperbolic coding chamber, which you're going to want to join to stay up to date on the newest tips, tricks, and cheat codes on the lead coding and competitive programming aspect of everything. So you may know by now that there's a binary, a slimmed down version of GPT-4 within every modern kernel today that was injected by an anonymous group that will remain nameless but may go by HCC. And to access this kernel, right, at any place in any editor on any OS, you're going to want to join the Discord for the secret keystrokes to activate this GPT-4 instance. So you're going to want that. And so we're just going to jump into using a robot to print the lexicographically smallest string. I sense great. My brain is saying I don't want to do this. So I'm going to try to do this. So we're going to put, yeah, I guess we'll just see if we can solve this. Let me think about the problem. So we have a robot to print the lexicographically smallest string. We're given a string S and a robot that currently holds an empty string T. T is not given to us. Apply one of the following operations until S and T are both empty. Remove the first character of a string S and give it to the robot. So remove from the front. The robot will append this character to the string T. Remove the last character of a string T and give it to the robot. The robot will write this character on paper. I see. So return the lexicographically smallest string that can be written on the paper. So, right, so we're given a string ZZA, and what they're saying is we can remove Z from the front, put it on T, right? Remove Z from the front again, put it on T, so now we have ZZ. Right, then we can remove A, which is the last character, and put it on T. And then the second operation we can do is remove the last character from T and give it to the robot, which would be AZZ. But apparently there would be a few different ways that you can actually make strings using this method. And we've had another problem like this before. And the way we tried to solve this one, made a function to reverse an array, right? And then what we did was we would remove a character from the front of S and push it onto the end of the array, which is technically T. Not really, but it's kind of like, well, yeah, this is kind of the letter that we're at, or the current combination of letters we currently have. And then we push it onto an array called potential, but we push the reverse. The reason we push the reverse is because the T operation will write the last character of a string on paper. So if we have the string Z, Z, A, and T, if it writes the characters by removing the last character, it would always print the word in reverse. If that's the case, then we should have been able to push reverse. I think the problem is you can generate more. I think what we're supposed to do is we have to figure. I think what we're supposed to do is figure out. Basically, we have a sequence of adding letters and removing letters. We want to generate all words. This method, then sort lexico. From there, we can choose the first word. And I think that actually makes the most sense. The problem is, if we look at what we submitted before, our current solution actually works pretty well, because we end up getting stopped at Badizfavi. The output should be Bevfaziti. I mean, the output should be Badevfazai, but we end up outputting Bevfaziti. Which means that these are all the possible strings we generated. None of the strings we generated were the best in its class. So I don't think we understand the way we're moving around the strings. So let's give it a string BDDA, see if we can make it make sense. So we have BDDA. They're saying we can add a character to the front. No. The first op is that we can remove the first character of a string S and give it to the robot. Basically, we can compress all this to remove the first character of a string and append it to T. So we have two ops. Remove first car from S. Append to T. And then the second one is, second op is remove last character of a string. Remove the last character of a string T, give it to the robot. We can ignore the give it to the robot part. Remove the last character. Remove last character of string T. I see now. I think the problem is what we're not seeing I think the problem is the way we're creating potentials is pretty much just by removing a character from the front, pushing it to the end, and then pushing that as a potential version. There are more versions possible. For example, if we have a string BDDA, right? If we run the example test case, we should generate pretty much all versions of just sliding these characters down one. Right? So we have BDDA, then we have D. DDAB. All right, we're pushing on the reverse. We have B. We have B. Wait a second. The answer is Badevfizi. Oh no. Okay, yeah, we still messed up. Okay. Right. So we have 4 versions that we push on because it's just we do the number of characters that are in the string. So we just move B to the end, push on the reverse, we get bad. Move the next one to the end, which would be DADB. DADA. we just print that. Right. I think I see what we're missing here. We can create more letters than we think we can, because we're just creating 4 different letters, 4 different versions by swapping a character, pushing it to the end, swapping a character, pushing it to the end, then printing that. We can create more characters than that. So I think is, can we get any letter to any letter? Any letter to any position? It doesn't seem to be the case, because if we could, then what should follow V instead should be, what should be here instead of V should be F. So we can't move any letter to any place. But it could be that at max, a letter can move at most So let's try and draw this out. We have BDDA, we have S is equal BDDA, and then we have T, which is an empty string. So what we can do is remove a character from the front, right, and append to T, which we get B. Here we can have another variable called P, which will be what we've printed, right? And if we were to keep going, right, we pretty much end up generating what we did before. BDDA, and we put D, and then print it. S equals DDA, we put B into T, then remove the character from the front again, we have D, remove character from the front, we have D, remove D, remove another character from the front, we have A, remove this, and then we print BDDA, and the string would be empty. Instead, what we did in the loop is we assumed that we're always going to have 4 characters to print. So we skipped a step with T. And all we did was just shuffle the characters around. We'd say, okay, we'll put B at the end, push that on. Push the reverse on, and then we said, okay, then we'll push the reverse of that on, so we should have a dabda. Dabda, dab. BDDA, take B, we put it at the end. DDAB, do have a DDAB. We move another D. We should have a D bad, a D bad. We do have a D bad. With this D, but here we should have a DDBA. Right, and then if we move A here, we have BDDA, which should be ADDB. Right. With these two operations, what first character from a string ask if we're about string 2. With the first character of a string as with the last character BDDA. There's another problem like this where you just have to figure out what kind of different strings you can create and then just generate all those strings and then you can sort them. But the word soup they're giving me here is confusing. Given a string S and a robot that currently holds an empty string T, apply one of the following operations until S and T are both empty. Wait a second, I think I figured it out. If you have a string BDDA, T is what the robot has and P is what we've printed. If we had BDDA, we put A on, right, because that's, well, we can't do that actually. We could remove B and put B here, right? From there, we can print B, right? And now this will be empty. But I think we have a divergence. If we printed, let's just change the string a bit to DCA so we can see it. If you push D here, right, then you could print BD, right? Then you could push C, and you'd push BDC. So you get BDC like that. But if you were to just remove the last character, DC, right, remove the first character from S appended to T, and then put C here, the second operation you can do is just remove the last character from T. So you actually get is, if you were to take all from T and put into P, you get B, C, D. Whereas before, the best I thought you could get was B, D, C, but you can actually get B, C, D. So you can get the same thing. You can get B, C, D, A and B, D, C, A. Now, what if actually we changed it from BDCA, or we kept it as BDCA? What if we had BDCA Z? If you printed it as is, one character at a time, you could get BDCA Z. But if you did load the whole thing in and then you could put it in reverse, you get ZACD. Now if we forget that for a second, if you just put in BDC, if you just put in DC, you could get CD. And then if you put in AZ, you could get ZA. I think what this means is you can swap a character with a character next to it. You could either get B, you could either get, let me remove all this again. You can either get B, ZACD, or BDCAZ. But you could also get BDC or BCD or BCDAZ or BCDZA. So how would we generate all those strings? I think that means you can swap a character with the character next to it. The right answer is Bedevzi. Something don't make no sense. I said you can only swap a character with the character next to it, but if you look at this, oh wait, let's look at the starting string. Z did only move one character, but F, okay, moved over 2 spaces. D moved over 1 space, and E moved a ridiculous distance. Or maybe we don't understand what lexicographically means again. Means you can swap. Actually, let's see. If I change the test case to A, B, C, D, E, F. Alright, so what if I should have did it in reverse order. F, E, D, C, B, A. F, E, D, C, B, A. A, B, C, D, E, F. Okay. If you get A, B, C, D, F, it has to mean you can move the the expected answer is A, B, C, D, E, F. I don't think this means that you can move any character to anywhere, because I think it just means you can print the string in reverse. So what if we move CBA to before it? Now if this turns out with A, B, C, D, F, there's no way. I move all these characters to just completely don't have a function key. Oh, if I move all these letters to anywhere, just gonna put A, F, E, C, D, B. A, B, C, D, E, F. Oh no, the answer now is A, B, D, C, E, F. Now what's the difference here? A, B, D. A, B, D. B, D, A, B, D, C, E, F. A, B, D, C, E, F. Now it can only move groups of 3. I think the string generation route might be a bust. What if we just go with the system route and we just say, we'll just do what they tell us to do. You're given a string S and a robot that currently holds an empty string T. Apply one of the following operations until S and T are both empty. With the first character of a string S and give it to the robot will append this character to string T. With the last character of a string T and give it to the robot will write this character on paper. So let's just try that. The way we'll do it is we will have, I can't delete empty spaces. I think we'll try it as a graph, and the robot's choices will just be nodes in the graph, and we'll just continue from there. We have a function robot, which will take an array S, which will be the starting string, and T, which will be an empty starting string. Then here we can just console. We'll just console.log array and return the first element to start. And then we'll just declare a function robot, which will take we'll just call it options, or versions options, and S, which should be a string, and T, which should also be a string. What we'll return is nothing. And then how could we turn these into options? So on each turn, we have the option to either take a character from the front of S and give it to the robot, or move the last character of a string T, and the robot will write this character on paper. So maybe we can count the robot writing it on paper as the string print, which will be empty. So remove the character first, remove the first character of a string S. We can do that. Just move the character from the front of S and move it to T. We also want to visit the option T. Or we also want to do the second operation as well. Here we could remove the last character of a string T and give it to the robot. Character of a string T and give it to the robot. With the last character of the string T, go to the robot. That would be equivalent of putting the last character in T into P. Okay. What's the largest string they'll give us? Because this might not work if the largest string. Okay, this is not going to work. S.length is equal to 10 to the 5. So graph-based version is not going to work. An exhaustive search of that size would be impossible. Yeah, there has to be a way that we can simplify this operation. There has to be a way we can simplify this graph. If we had infinite runtime, this would work. So we could just run every option. We don't have infinite runtime, which means it's likely not a possible method. Maybe we are closer to something with the other version. That's the only way it could work. I think the other version was onto something. If we go back to this version, maybe what we're seeing is that once you move a group into the printed section, for example, it moves to P, you've printed B or something like that, you can reverse all the other letters up to a certain point, which is why E can move so far up E is V. Why would 4 be the character there? Maybe it's not 4. If we have 1, we have 5. We have 8 characters. You remove 1, you get 7. Guess we can see how far a letter can move. Given A, F, C, D, B, and B was able to move up pretty far, but why couldn't C move up as well? Swap these two, you have DB, then you'd have BC, have A, B, D, C, F. I don't. By this for V. I don't understand. How far can these characters move? A, B, D, C, E, F. A, B, D, C, E, F. You could also push the non-reverse on as well. We don't even get the right answer anymore. With the first wow, there wasn't a lot of successful submissions to this. Only were 11K submissions and only 2K were 11K submissions and only 2K were accepted. A lot of people tried though. You're given a string S and a robot that currently holds an empty string T. Given a string S and a robot that currently holds an empty string T, apply one of the following operations until S and T are both empty. Given a string S and a robot that currently holds an empty string T. Given string S and a robot that currently holds an empty string S and a robot that currently holds an empty string, apply one of the following operations until S and T are both empty. Apply one of the following operations until S and T are both empty. The first character of a string S and give it to the robot. Roll append this character to string T. With the first character of a string S, give it to the robot. With the first character of a string S, we know what letters to take. think I have this problem figured out. I think I have it figured out. The robot is basically a stack. The reason we end up, or maybe I finally understand the question, the reason we get bedev fuzzy is because once you put strings into S, you can't put them back. Once you put strings into T, right, you go from S, the first character from S goes on to the end of T, you can't change the output order now. You're locked in. So the reason you end up with bedev fuzzy is by optimizing, choosing the lowest, the lexicographically smallest characters and then printing the remaining stack. For example, you get ByDisFV to start. Now just quickly explain this. You get ByDisFV to start, right? So you take B, which is this lexicographically smallest character, right? Now above we'll have a stack, which is equal. A stack which is basically standing for T, because once you get T, you can only print the letters one by one, right? Like a stack. You take the first one on, you put it onto the top. First one on, you put it on. You put it down. Because the second operation you can only do, right, is remove the last character of a string T and print it. So if we have ByDisFV, the reason the answer is bedev fuzzy is because we'll push Y onto the stack because it's not the smallest lexicographical string we could make. We'll take D, right? Then we'll take I, right? We'll keep that onto the stack. And then we'll put Z onto the stack. And then we'll find F, right? And then we'll put F onto the stack. And then we'll put V onto the stack. And then we'll find E, which is the smallest character. So we'll just print that as is, right? And then what we end up, right, the remaining characters in the stack, since the second operation you can only do is remove a character from the end of T and print it, you end up with bedev fuzzy. Because the last, once you reach the end of the string, the print order is already locked in. All you can do is take elements from the top of the stack and print it. My question, or the reason I haven't implemented this yet, is because it's unknown why one is taking B, D, and E, right? It's unknown. Do we just iterate from the front of the string to the end and find the smallest lexicographical string we could by just taking the first character? We just get pretty much B, D, E is the best we can do by going front to back, and then we just print the rest of it? Maybe that is it. So I think we can try that. So iter front to end, keep track of smallest car, and stack. Keep track of the smallest character in the stack, and then try and make smallest prefix, then dump remaining characters. If we can do that, I is equal to 0, I is less than s dot length, I plus plus, what we're going to do is we're going to have the stack is going to be the array, and then we're also going to want our answer, which is going to be an empty string to start, and we're just going to return answer. And I think we should be able to do this. We'll say smallest car equals s sub 0. Or maybe it doesn't need to be s sub 0. For example, when we're given a string CBA, given the string CBA or CAB, the answer we want is actually ABC, because the smallest character to start would actually be A. And so we probably have to search through the string first. First find smallest car. Min of S sub 0. No, it would just be and let's see if we can get the smallest character to print. Number is not assignable to type string. That would be car 8 line 12. Taking the math.min of smallest car. I forgot how you get the ordinance of a character in JavaScript. Let me just check real quick. Oh, it's car code at. Number is not a type, but a type string. I guess we can't use math.min. Actually, we can. But smallest car is a character. I see what they're saying. We'll just use ternary. We'll just say if smallest car is less than S sub I, then we'll just set the smallest car. Otherwise, we'll set it to S sub I. Smallest character would be A. Okay. So we'll just do that then. We'll pretty much add it to the stack until we reach the end of the string, and then we'll just add it to the end, I guess. So now we have the smallest character. Now you want to pretty much do another for loop, except this time we'll make use of the stack. And we'll say as we're iterating throughout the string, we want to push things onto the stack, but only if it's greater than the smallest character. So we could say maybe if s.car, s sub I dot car code at 0 is greater than smallest car dot car code at 0, and we'll do stack dot push s sub I. Otherwise, we'll just do answer dot plus equal so for BDDA, right, smallest character is A, so we go until, all right, if s sub I car code at 0 is greater than car code at 0, and it would be, so we push B, D, D, and A on B, D, and D onto the stack until we find A, and then we just do answer dot plus equal s sub I then do answer plus equal stack dot. Oh, we want actually the stack in reverse, because if we join it, it would be in the incorrect order. To be A D, it'd be B D D. What we want is D D B. D D B. If that's the case, then we could just add them to the front instead. We'll just do unshift. And so A D B D D becomes D D B. Well, no, the string is B. What is the input string? The input string is B D D A. If you're pushing it onto the end all the time, you get D D. You push B onto the end, you get B D D A. You get B D D. If you join it, we'd get A B D D. We want the opposite. We want to push D on, put B on, then D onto the front. All right, so unshift should get us what we want. This should get us the right answer for this. And then if we switch to Bedi's for V, we should fail because B is the smallest character. So we'll push B on. Then we'll add Y. Now we have D. The question is, why shouldn't we push Y on? Why should we wait for D? B. It looks like we should just sort the string by the smallest characters and try to find those characters. So instead of smallest cars being 1, it looks like it should just be set to S. In fact, an array that we just do smallest cars dot sort. Then we can remove finding the smallest character. What we're doing is just searching through the string for those smallest characters. So what we'll do is basically just say if S sub I equals smallest cars 0, and we do answer plus equal S sub I. Otherwise, we do stack.unshift S sub I. No, we don't want to do plus equal. Actually, plus equal S sub I is fine, but it actually might be more readable if we just say smallest cars sub 0, and then we do smallest cars dot or we could just do plus equal smallest cars, and it's not even the smallest cars, it's just sorted cars. Just take a character off of the front. Take the character off of the front. If we find one of the smallest characters, we'll take the character off the front. And then if we reach the end of the array, we'll just join with the stack. So if we run this in our head with bedice for v, sorted, we get b, d, e, f, right? But if we follow this to the string, all we really get is b, y goes on the stack, d, I goes on the stack, z goes on the stack, f goes on the stack, v goes on the stack, e, and then we just print the stack in reverse. Oh my god, I think this is it. Oh. We output, we have BAC, they output ACB, we output ABC. Sorted would be ABC. So sorted we get ABC, and then we search through the stack, we put B. We find A, we have B on the stack, we add A to the answer. And then we get to C. Well, we're looking for B, we didn't get to find B. So put C onto the stack. And then we just join it. We get A, B, C. But let me think about that. We're adding B onto the stack from the front, and then we add C onto the stack from the front, which would be CB. Oh, our output is ACB when our output should be ABC. So we know that. Let me just. I need to see if sorted cars is coming out correct. Or I should have changed it to BAC. Yeah, we do get ABC. So S sub I equals sorted cars sub 0. Answer plus equals sorted cars dot shift. So now you have B, C. Well, we have ABC in the sorted cars, and the string that we have is BAC. So we're at B, and B does not equal A. So we add B to the stack, which would be B. And now we check if A equals A, which it does. We do answer plus equals A. So now answer equals A, and B is in the stack. To the last character, does B equal C? It does not. So we unshift C. So now you have CB. And then we join the stack. We join the answer with the stack, we get ACB. BAC, ACB, ABC. BAC, ACB, AC, BAC, AB, BAC, ACB, ABC. Expected. BAC, ACB, ABC. What if we did something like this, where if sorted, if s dot length less than or equal to 3, we just return sorted cars dot join by space. Looking for age. What? We find F. Now we're looking for H. We can't find H. So we just do OP. But the best we could have done was go down to N. We could have got N. Oh, and then printed the rest out. Oh. Does it at least show you how many test cases it passes? It's not. Oh man, I feel like we're so close to this one. But maybe I'm thinking too simple. I'm starting to think this is a graph problem, low key. I started thinking it was a graph problem about 20 minutes ago, but maybe it actually is. So, yeah, we're gonna wrap it up there. And that's day 118.